At 2:11 a.m. on February 3, 1943, inside the dimly lit No. 4 assembly bay of the Willow Run bomber plant in Michigan, a welder named Robert "Bobby" Kellerman stumbled as he adjusted the torch in his gloved hand, the metallic echo of his misstep lost beneath the thunderous rhythm of hundreds of B-24 Liberator components being forged around him. The factory ran 24 hours a day, 7 days a week, churning out heavy bombers faster than any assembly line in the country. Yet on that freezing night, it felt as if production was collapsing into chaos. Snow pressed against the rattling windows, sparks danced in frantic showers, and Bobby, half drunk from the cheap rye whiskey he had smuggled in to stay warm, leaned over a half-finished fuselage joint that refused to cooperate. What happened in the minutes that followed would be remembered by almost no one, documented in almost nothing, yet quietly accelerate the output of the single largest aircraft factory the United States had ever built. Bobby had been a welder for nearly a decade before the war, working for railroads, then shipyards, and finally landing here at Willow Run, the nerve center of America's ambitious promise that a bomber would roll off the line every 55 minutes. But the truth behind the propaganda posters was far less heroic. The factory was plagued by bottlenecks, slowdowns, and welding failures that kept entire sections of the line stalled for hours. Most problems came from the same source: the complex intersection welds around the B-24's bomb bay, where aluminum spars, reinforcement ribs, and load-bearing frames met in awkward angles. The original designers in California never had to assemble at scale. At least 30% of these welds required rework every day, and rework meant downtime. Downtime meant fewer bombers in the sky. Fewer bombers meant fewer Americans coming home. The foreman blamed operator inconsistency. The inspectors blamed substandard material. Headquarters blamed the learning curve. But the welders, the ones actually breathing the fumes, burning their arms, hearing the metal crack when it cooled wrong, knew the truth. The blueprint didn't match the battlefield of the assembly line. The aluminum alloy Ford had sourced in bulk reacted unpredictably to temperature shifts, especially in winter. Joints cooled unevenly, contracting too fast at the intersections and splitting microfractures that inspectors spotted hours later. It wasn't sabotage. It wasn't incompetence. It was physics. Physics that the manual refused to acknowledge. Bobby had lost 2 friends over those failures. Not to death, but to transfer or firing. The unsaid rule was clear. Bad welds were the welder's fault. Always. One of his closest friends, Tom Granger from Sacramento, used to joke that his entire life had become one long argument with aluminum. Tom had been reassigned to sweeping floors after 3 consecutive failed inspections. Another, Johnny Russo, who had come from a small garage in Ohio, burned out and enlisted. He wrote once from Florida, saying he missed the smell of hot metal more than he expected. Bobby kept their names in his notebook, because in places like Willow Run, loyalty grew in grease, not glory. On this particular night, Bobby was assigned to the problematic Station 14B, the line that joined the lower fuselage segments before they moved toward final assembly. The section was notorious. Even senior welders avoided it. The angles were tight, the torch had to be maneuvered upside down, and the metal cooled too fast when drafts slipped through the hangar doors. Bobby's hands were already numb. His breath fogged the lenses of his mask. He leaned forward, brought the torch down, and watched the puddle of molten metal quiver as if indecisive. His stumble wasn't dramatic. It wasn't violent. It was just one sloppy shift of weight as he reached for the adjoining rib plate. The torch dipped a millimeter too deep, held heat a fraction of a second too long, and left a slight, unintended curvature along the seam, a gentle arc rather than the straight line he had been instructed to maintain. He muttered a curse, pulled back, steadied himself, and finished the job, assuming the inspector would flag it and send it back to the rework station as usual. But when the piece cooled, something odd happened. The microfractures that usually appeared along the convergence point, the tiny spiderweb cracks that made inspectors shake their heads, were absent. The metal lay clean, smooth, slightly contoured, but structurally flawless. He touched it once, twice, hit it gently with a mallet. Nothing. It held firm. He stared at the seam, confused, then laughed under his breath. "Well, I'll be damned," he said to no one, though the woman at the next station, Mabel, glanced over, her face half lit by sparks. Bobby didn't know it yet, but his drunken stumble had introduced a subtle, crucial modification, a heat distribution curve. By inadvertently spreading the thermal load in a soft arc rather than a rigid straight line, he had allowed the aluminum to cool more uniformly, relieving the internal stress points that usually tore themselves open. What designers had struggled to solve with equations and prototypes, he had triggered by accident with one clumsy movement. The next morning, the inspector paused at the joint. He squinted. He tapped the metal. He checked his clipboard. He marked it, pass, then hesitated long enough that Bobby considered confessing. Instead, he shrugged and let the man walk away. For the first time in months, the fuselage segment moved through the line without delay. The foreman noted the anomaly, but chalked it up to luck. By afternoon, fate intervened again. Station 14B backed up behind Bobby's shift change replacement, a younger welder named Henry Whitaker who had been struggling with the same joint for weeks. His welds failed. They cracked. They were sent back. Finally, exhausted and embarrassed, Henry approached Bobby and asked what trick he had used the previous night. Bobby hesitated. He didn't want to admit he had been drunk, but he also didn't want Henry ending up like Tom or Johnny. He knelt beside the joint, traced his gloved finger along the subtle curve, and explained that the heat needed to linger a fraction longer on the outer angle, letting the metal breathe before the contraction pulled inward. Henry tried it. The metal cooled cleanly. He grinned. Stunned. "What do you call that?" he asked. Bobby shrugged. "Mistake," he said quietly. "A lucky one." Word got around the bay by sundown. Not officially. Nobody would dare record such a deviation from procedure, but whispered over toolboxes, exchanged between shifts, shared the way soldiers shared rumors that weren't true until they were. Welders began copying the curve. Within hours, reworked joints at Station 14B dropped by nearly half. By the next morning, the bottleneck that had plagued the line for 3 months cleared. Fuselage segments reached final assembly faster than anyone had seen since the plant opened. No memo was written. No superior congratulated anyone. But on February 5th, at 9:40 a.m., the first supervisor noticed the numbers. Output had jumped. Not dramatically, not in a way newspapers would print, but enough that Ford executives in Detroit asked why Willow Run suddenly looked as if it had found its rhythm. Only a handful of welders knew the truth. A drunk stumble, a flawed weld, and a curve no engineer had ever calculated had quietly altered the tempo of a factory, meant to win a war through speed. By the evening of February 6, 1943, the quiet rumor that had begun as a whispered confession between two welders had already evolved into a full, unofficial practice. The curve, that subtle, almost imperceptible change in technique, spread through the welders' ranks like a secret handshake unseen by supervisors but felt in every shift. In a plant as vast as Willow Run, small murmurs traveled miles. The assembly bay echoed with engines being tested, metal hammered into compliance, and conveyor belts rattling under the weight of bomber frames. Yet beneath all that noise was another rhythm, softer and more human. Welders repeating a movement they barely understood but trusted instinctively. Bobby Kellerman watched it unfold from a distance he did not intend. He never promoted the method. He never claimed ownership of it. In fact, he avoided the topic entirely. But Willow Run had a way of noticing anomalies. The plant was a living machine, one that sensed imbalance and corrected itself. Except this time the imbalance was upward. Productivity rose in ways management could not fully explain. Weld failure rates dropped, especially in the infamous Section 14. Engineers were perplexed. Inspectors, for the first time in weeks, weren't falling behind. And foremen, who usually blamed workers for every lag, now looked around as if wondering whether to congratulate them or demand an explanation. The strange thing was that none of the welders could articulate what they were doing. When asked by a senior foreman why their joints suddenly looked more compliant, one welder shrugged and replied simply that they had figured a better flow. It was an answer vague enough to satisfy the curious but not alarm the strict. No one dared mention the curve. If the method were discovered, management might forbid it for deviating from the manual, and the manual, written months before in a quiet office in California, was treated as if it were scripture, even when it clashed violently with the realities of cold metal and frantic deadlines. That tension between blueprint and battlefield had always bothered Bobby. He remembered the night Tom Granger had broken down beside his locker, exhausted after being blamed for welds everyone knew were impossible to perfect the way the engineers demanded. The manual wasn't written by anyone who ever crawled under a bomber, Tom had said, wiping sweat and soot from his forehead. It was written by men who never had to hold a torch. Now, with the curve spreading silently across the assembly line, Bobby felt a flicker of vindication on Tom's behalf, though he knew Tom would never see it. On February 9th, A minor storm swept through Michigan, sending cold drafts slithering into the bay every time the delivery doors opened. This was the kind of weather that always crippled the aluminum, making it contract more violently and triggering fractures even in the best of welds. But that day, something unusual happened. The cracks didn't appear, not in Station 14B, not even in the notoriously troublesome junction near the lower spar. The metal cooled calmly, the welds tightened without stress, and the inspectors passed segments through with mechanical efficiency. A few welders exchanged glances. Henry Whitaker mouthed, "No way," under his breath. Even Mabel, who rarely showed emotion during shifts, allowed herself a small smile. It didn't take long for the foreman to notice. One of the supervisory engineers, a tall man named Clifford Hartwell, stopped by the station late in the evening. Hartwell had a reputation for being rigid, a man whose loyalty lay with blueprints over human improvisation. He inspected a joint, frowned, then inspected another. He ran his finger along the subtle arc left behind by the curve, though he didn't yet realize what it meant. "This seems different," he muttered. "Who welded this section?" It was Henry's weld. Henry froze, looked at Bobby, and instinctively lied. "Just followed the book, sir." Hartwell nodded without conviction. He stood silently for a few seconds, then walked away, leaving an unsettling trail of curiosity behind him. The moment he disappeared, Henry exhaled with a tremor of adrenaline. Bobby didn't say a word, but he knew what Henry was thinking. If supervisors figured out the welders weren't following protocol, punishment could be severe, even dismissal. And during wartime, dismissal from a defense plant wasn't just losing a job. It meant being drafted. Nobody at Willow Run wanted to fight the war from the sky when they could fight it on the ground with a torch. The next morning, February 10th, the plant superintendent announced that Detroit headquarters wanted updated numbers on production efficiency. Willow Run's output had jumped 3% in 48 hours, an increase so abrupt that it bordered on impossible. The superintendent asked foremen to provide explanations for the improvement, but none of them had one. They cited worker dedication, experience, shift consistency, and improved material stability, though they knew perfectly well that none of those factors had changed. With leadership watching more closely, the welders had to become even more discreet. Some began performing the curve only when the inspector was out of sight. Others practiced making it faint enough that it blended with standard procedure. They hid the technique not out of fear alone, but because they sensed its potential, a potential not yet understood, not yet protected. If exposed too soon, it might be banned rather than adopted. Yet even with greater scrutiny, the curve kept spreading. In a factory of nearly 40,000 workers rotating through 3 shifts, news traveled far. Welders in Assembly Bay No. 2 heard from welders in Bay No. 4. Someone in the wing assembly line replicated the curve on a hunch, and the result held strong. Another welder, in the tail section division, adopted it while repairing stress fractures on a B-24 destined for 8th Air Force operations in Europe. The more it spread, the more difficult it became to hide. The production numbers kept rising, like a quiet pulse racing through the veins of the plant. It was only a matter of time before someone from the outside noticed. On February 14th, a small team of inspectors from Consolidated Aircraft, the original manufacturer of the B-24, arrived at Willow Run for a scheduled review. They were accustomed to lecturing Ford on assembly speed, tolerances, and weld precision. They expected to find their usual list of grievances. Instead, they found welds they could not categorize. The joints in Section 14 held cleaner under stress tests. The metal displayed fewer internal fractures. The sections that once bottlenecked were now flowing smoothly. One inspector, a man named Robert L. Warren, asked the same question Hartwell had asked days earlier. What changed? The foreman shrugged, though the tension behind his eyes signaled that he was aware something had changed. He simply didn't know what. "The men have gotten better," he replied. Warren examined the curve with the trained eye of someone who had welded before becoming an engineer. He paused, leaned closer, and finally said, "This isn't in our manual." That sentence sent a brief chill through the welders within earshot. Warren wasn't angry. He wasn't even accusatory. He was curious, and curiosity could be more dangerous than anger. If engineers took interest, they would start asking questions. If they asked questions, someone might tell the truth. And if someone told the truth, the entire line could be forced to revert to the old method, the slow method, the method that cost time, and indirectly, lives overseas. That night, Bobby found himself alone again near Station 14B, staring at a half-welded joint, the curve shimmering faintly beneath the factory lights. The hangar was quieter at midnight. The vibrations softened. The air stilled. He could feel the weight of what had begun, an accidental discovery that now pulsed through the largest aircraft factory on Earth. He wondered whether he should stop, whether he should confess, whether he should disappear into another assignment before someone connected the dots. But then he remembered Tom's cracked voice, Johnny's letter from Florida, the faces of welders who had been blamed for problems they didn't cause, and he realized the truth. The curve wasn't his secret anymore. It belonged to every welder who had ever tried to make the impossible easier. It belonged to the men whose hands had learned what the blueprint never could. He lowered his mask, steadied the torch, and lit the flame. The metal glowed, softened, bent to his will, and once again, without hesitation, he drew the curve. By February 17, 1943, the quiet transformation inside Willow Run reached a point where even the most oblivious supervisors could no longer pretend nothing unusual was happening. Output charts showed a rise that defied historical patterns. Efficiency curves bent upward in a way that looked almost artificial, as if someone had tampered with the numbers. But the numbers were real. Every hour, bomber sections moved through the assembly lines with a confidence the plant hadn't known since its chaotic opening months. And yet, not a single official order had changed. No new equipment had arrived. No new procedure had been announced. The improvement came from somewhere else, somewhere low, somewhere invisible. The welders kept their secret alive the way soldiers protect a comrade under fire, wordlessly, instinctively, without expecting credit. They guarded the curve with a sense of brotherhood born out of exhaustion and survival, not rebellion. They weren't trying to deceive the plant. They were trying to keep it working. But the closer production crept toward headquarters expectations, the more executives demanded answers. The factory couldn't improve itself, they reasoned. Someone had done something. Someone had changed something. The engineers in charge of quality control began conducting spot analyses on random fuselage sections. They collected samples and performed stress tests in a small room at the edge of the bay, away from the welders but close enough for them to feel the tension radiate through the walls. One morning, a pair of engineers, both wearing crisp white coats that contrasted sharply with the welders' soot-caked uniforms, examined the curved seams under magnifiers. They whispered to each other, concerned but intrigued. "This is not consistent with the prescribed method," one muttered. "It holds better," the other replied quietly, as if afraid of being overheard. "That's irrelevant," the first engineer said. "It isn't approved." That exchange was relayed by a welder who happened to be sweeping near the door. Within an hour, the entire section knew about it. The fear spread faster than the curve. If the engineers decided to intervene, the technique would be banned on the spot, not because it failed, but because it succeeded without authorization. That night, Bobby sat alone during break, his lunch pail untouched beside him. His hands were blackened from work, but beneath the grime they trembled with something he hadn't felt since before the war. Dread. He thought of the welders who relied on the curve now, welders who couldn't afford to lose their positions. He thought of those who had written to brothers overseas, proudly saying they were helping build the machines that would keep them alive. He pictured those machines failing again, one cracked weld at a time because someone in an office decided the curve wasn't in the manual. Around midnight, while the plant thrummed with the metallic breath of industry, a sudden commotion rippled near the entrance of Assembly Bay No. 4. A B-24 fuselage, recently completed, had been scheduled for deep stress evaluation, the kind of test usually reserved for verifying major design changes. Consolidated aircraft engineers wanted to know why Willow Run's numbers were climbing so abruptly. They demanded live demonstrations. They wanted data, and data required testing. The fuselage was mounted on the rig, its frame stretching under steel clamps. In the observation room above the floor, engineers, foremen, and inspectors gathered behind glass. Below them, welders pretended not to notice the scrutiny, though their hands revealed their anxiety. Torches held too tightly, tools gripped too firmly. Bobby watched from a distance, shoulders stiff. The test began. Hydraulic arms pressed against the fuselage from various angles, mimicking the stress of flight. Pressure changes, torque, vibration. The welders had seen these tests before, and they always braced for the same moment, the crack. It usually came once the metal reached a specific tension threshold. A sharp sound, like ice breaking. A white chalk line appearing along the weld. A failure, but not this time. The fuselage held. The curve held. The test pushed further, harder than usual. The hydraulic arms extended a fraction beyond their standard limit. forcing the aluminum into unnatural strain. Again, the welds held. A murmur spread through the welders on the floor. A quieter, more bewildered murmur spread among the engineers in the room above. When the test ended, the observation room emptied in nervous silence. The welders did not cheer. They did not celebrate. They simply exchanged glances of exhausted relief. But success was a dangerous thing. 2 days later, on February 19th, a formal inquiry began. Supervisors were instructed to collect information on unauthorized procedural deviations. The phrase circulated through the plant like an accusation. Questions were asked. Welders were approached. No one confessed. Not a single worker mentioned the curve. They lied not out of disloyalty, but out of loyalty. Loyalty to each other. Loyalty to the planes. Loyalty to the soldiers depending on those planes. Yet the inquiry did not stop. On the morning of February 20th, a memo was posted near the time clocks. Effective immediately, all welding methods are to adhere strictly to Technical Manual 24B, Section 4. Deviation will result in disciplinary action. The welders read it with an ache in their chests. The curve was forbidden now. Officially forbidden. But the truth was that the manual's method had never worked under winter drafts or rapid production demands. If they obeyed the memo, the cracks would return. And if the cracks returned, the delays would return. The plant would slow. The war effort would suffer. The welders held a quiet, unspoken meeting across shifts, not around a table, not in any official capacity, but in the small conversations exchanged on stairwells, beside lockers, near the vending machines. No one dared speak openly, but a shared question hovered in the air. Do we stop, or do we keep doing what we know works? The answer emerged naturally without a vote. They would continue, only more carefully, more discreetly, more invisibly. The next day, the welders practiced making the curve so subtle it could pass as an accident. They blended the arc into the straight line pattern just enough that an untrained inspector might chalk it up to hand variance. Some learned to smooth over the curvature with quick brush motions, making the joint appear uniform on the surface while maintaining the internal heat distribution advantages. Others perfected the technique of adjusting their torch angle in ways that produced the same thermal spread without leaving a visible contour. They became ghosts inside their own factory. The plant continued producing faster. Headquarters noticed again. They attributed the improvement to worker resilience and streamlined operations. They were wrong, but the welders accepted the misdiagnosis. Credit wasn't the goal. Survival was. Then came the turning point, the moment that validated the curve beyond the factory walls. Late in February, the first B-24 containing a fully curved weld fuselage segment reached a training airfield in Kansas. The aircraft, piloted by a young lieutenant named Harold Montgomery, encountered unexpected turbulence during a high-altitude maneuver. Normally, this kind of stress pushed the lower fuselage welds to their limit, but instead of hearing the familiar groan of aluminum under strain, Montgomery noted something unusual in his flight log. Plane responded clean. No flex cracks. Feels sturdier than previous models. That note traveled back to Willow Run through channels no welder ever saw. It was buried in reports skimmed by analysts, overlooked by officers. But then another report came. Then another. Pilots were noticing something subtle but undeniable. The new bombers were holding up better. Still, no one connected it to the welders. At Willow Run, the welders continued their quiet rebellion, continuing a method that existed only in the space between knowledge and instinct. Bobby performed the curve with a steadiness that belied the origins of the technique. What had begun as a drunken accident had become a disciplined craft, a secret art passed from hand to hand. But secrets, especially successful ones, cannot remain hidden forever. And someone, was about to expose it. The revelation came not from an engineer, nor a supervisor, nor even a curious inspector. It came from a pilot, a man who had no idea he was about to unravel one of the factory's most carefully guarded secrets. On March 3, 1943, Lieutenant Harold Montgomery, the same pilot who had noted the unusual stability of his training aircraft days earlier, arrived unexpectedly at Willow Run. His bomber had developed an unrelated electrical issue after a training exercise, and the air depot assigned him to accompany the aircraft to the plant for a rapid inspection. Pilots rarely set foot inside the assembly bays. Their world existed thousands of feet above, not in the welding pits below. But Montgomery was curious by nature, a man who liked to understand the machines he flew. And when he walked past Station 14B, he stopped. He watched a welder, Henry Whitaker, guide his torch in a motion Montgomery didn't recognize. Pilots were trained to read every shudder and vibration of a bomber, but the language of molten metal was foreign to him. Still, something about that movement felt familiar. It was the same smooth confidence he felt in the air, the subtle difference he couldn't name. "What do you call that?" he asked. Henry froze. Bobby, who had been working 10 feet away, felt every muscle in his body tense. Montgomery wasn't a supervisor, but he was military, and military eyes saw everything. "It's just a weld, sir," Henry said quickly, lowering his torch. "No," Montgomery insisted, stepping closer. "I've seen welders before. That's different. And whatever you did back there," he pointed toward the fuselage of his aircraft in the distance, "it made that bomber fly cleaner than any B-24 I've trained with." The words echoed through the bay like a dropped tool. Pilots never praised welds. They complained about noisy bulkheads, stiff controls, sluggish climbs. But welds? Welds were invisible to them. Montgomery's curiosity, innocent as it was, threatened to pull the entire mask off the welder's secret. Henry hesitated, looking at Bobby for guidance. Bobby stepped forward, wiping his hands on a rag, his voice calm but deliberately vague. "Sometimes the metal needs a little coaxing," he said. "Cold drafts at night change its mood. We adjust, that's all." Montgomery studied his face with the frank sincerity of a man who spent his days trusting strangers with his life. "Well, whatever you're doing, you saved me a rough landing last week and probably more than that." He meant it as praise, but praise was the last thing the welders wanted. Praise drew attention. Attention drew scrutiny. Scrutiny killed the curve. When Montgomery finally left, Henry let out a shaking breath. "He's going to tell someone," he whispered. "Maybe," Bobby replied. "But maybe that's not the worst thing anymore." The next week, Willow Run received a delegation of engineers from both Ford and Consolidated Aircraft, a larger team than usual, with more authority. They came armed with questions, flight reports, inspection logs, and a growing list of anomalies they could no longer ignore. They walked the line slowly, like detectives searching for a clue that had been hiding in plain sight. It happened near the end of their inspection. One engineer, a quiet man named Theodore Mallory, stopped at a fuselage section welded by Henry 2 days earlier. He didn't say a word at first. He just traced the curve with the tip of his pencil. Then softly, "There it is." The room stilled. Foremen leaned in. Welders froze. Mallory turned to the superintendent. "This is what's changing the numbers." The superintendent frowned. "That's not in the manual." Mallory nodded. "Yes, which is why it works." The statement hung in the air like a spark suspended before falling. For the first time, someone with authority, real authority, saw not disobedience but innovation. He asked who had first used the method. Every welder remained silent. Not one pointed to Bobby. Not one broke the code of loyalty. But their silence alone was an answer. Mallory did not punish them. Instead, he requested a meeting with the engineering board. Within 2 weeks, the curve was evaluated, tested, dissected, documented, and finally approved. The official wording in the new technical bulletin read, "Revised weld contour recommended for improved stress distribution at fuselage intersections." No names were included. No welder was credited. The technique that had saved time, metal, and possibly lives entered the documentation anonymously, attributed only to observed field variation. By April, Willow Run achieved the milestone the government had doubted for months. 1 bomber rolling off the line per hour. Newspapers celebrated Henry Ford. Executives congratulated each other. Posters proclaimed the triumph of American industry. Not one mentioned the drunk welder who had stumbled into history. After the war, Bobby Kellerman returned to a quiet life in Michigan. He married once, raised 2 children, and worked at a small machine shop where no one ever asked about bombers or curves or factories that breathed like living giants. He kept his welding helmet on a hook in the garage, its surface still scarred from sparks long extinguished. On summer nights, he sat on the porch and listened to the distant sound of freight trains, the same rhythm that had filled his ears during childhood. He rarely spoke about the war. When his son asked what he had done back then, he simply replied, "I made sure things held together." But the men who had worked beside him, the welders who had lived through those impossible months, remembered. They spoke his name quietly at reunions, lifting their glasses in small private toasts. They knew the truth tucked inside the machines that crossed the ocean, that sometimes wars turn not on grand strategies or famous generals, but on men who bent the rules because they understood the metal better than the manual. And somewhere, in the silent archive of an aircraft factory long since shuttered, a faded blueprint still carries a revision line that changed everything. A gentle curve, born from a moment no historian ever documented, made by a man no metal ever found. If you found this story, then the memory of men like Bobby Kellerman lives a little longer. And sometimes in history, that is all the recognition they ever get, and all they ever needed.